All right, so we're moving on to 11E and 11F. Last few sessions, we've covered indefinite integrals. You had to learn how to anti-derive, even though technically we haven't talked about why the antiderivative actually is the area under the curve. That's after we do average value, and then I might link it back to see if I can teach you. Otherwise, you can watch Khan Academy's proof. It's pretty good as well to explain it. But today we're now doing area under the curve, and again, we're not telling you how it works. It's just more, this is what we're going to do. We're going to anti-derive, and it represents the area under the curve for now. So this is called the fundamental theorem of calculus, that when you're anti-deriving, or that symbol is finding the integration between A and B, meaning finding the area of any curve, f of x, between the points A and point B, you're finding the area under the curve, and it's given by whatever the function is. So anti-derive f of x means it gives you the previous function. So derivative of some function gives you this f of x curve, right? So f of b, well, I'll do a little b, minus f of a. In a nutshell, you can kind of picture like this. Shh. Thanks, team. If you have the curve f of x, and we're saying that anti-deriving it gives you the area, so between A and B, so the area of B, if you did f of B, it's finding the area all the way up to B, and you minus the area of f of A, then you get the area between A and B. Okay, because if we're saying that anti-deriving is the area under the curve, then we're saying f of b is the area between, well, f of b here of the function, and then f of a must be then the area from A and below. And so hence, when you do f of b minus f of a, you're essentially finding the area of between A and B. Okay? Now, a couple of things here. Where f of x is the antiderivative of f of x, this is known as the definite integral. Definite integrals do not have a plus c. It is the value. It should give you a value, kind of like your gradient function versus the gradient at a certain point. Then finding the definite integral between 2 points should give you a value and not a function. Definite integrals calculate the area between those 2 points under the curve, and it calculates what we call the net area. This means there is a positive or negative, and it's different to total area. So if I gave you if we said, let's find the antiderivative or the area between for a y equals x curve. So if I said antiderive f of x dx, but between -1 and 1, what we can already say is that the area under this curve and under this curve between -1 to 0 and 0 to 1 should actually be the same. But if you actually integrate, because there's a net sign, it means that above the x-axis is positive and below the x-axis is negative. Those two are going to cancel out, even though we know there is a total area that's doubled. It's doubling the triangle. So this triangle down here has a different area to this one based on a sign point. So this one would be negative. This would be a positive. So if you type on your calculator, it will end up being 0. So it depends on the question. If the question asks you to find total area, you have to take the negatives and make them positive. If they ask you for just the area, then you're finding the net area. So it depends on, are they asking for the net area or are they asking for total area? If they're asking for total area, it's like distance versus, speed versus, what was the other term? Velocity. Okay, there's that direction to it. All right, a couple of properties to fill in. We'll talk more about that net area problem when you start dealing with problems below the x-axis. Here we go. If you're finding the area of a curve between A and A, what do you think the area would be? 0. And then these are some other properties. If you've got a constant k multiplying to the function, you can take k constant out and it becomes a, b, f of x dx. If you add two functions together, you can separate them individually as well. So you can antiderive it for f of x dx plus a to b of g of x in the same interval. So you can do them separately. If you have an interval where you want to split the area, kind of like the one I've got up here, area 2 and area 1. If we want to find total area, we have to do them separately because one's going to be negative and one's going to be positive. So you can split them up between A to B. We can have a second point A to C and then C to B. So here, what I'm trying to say is that you can split, that function up to say from A to C and then C to B. They're two separate calculations. So A to C of f of x, it's missing a dx there, and then C to B of f of x dx. Just separating the two, it is possible, and that's the same thing as saying of A to B when you're separating them into two components. Usually do that when you know that part of the graph is going to be a negative, and you separate that to combat that negative area. And your last one, A to B, because we know that it's f of b minus the f of a, you can actually also write it as the reverse, because you can look at it as the area under the curve. And this is the same thing as saying b to a of f of x dx. Okay, so there's just some definite integral properties that you'll find useful, especially in your textbook. In the second page, I think it was question 4. If you flip over, it'll be useful for question 411E as you're answering these questions later. Okay, so these type of questions. All right, so let's do a bit of practice. So you got some properties here. Let's do the first one. Let's do example 1A. Let's do some antiderivative rules that we've learnt previously, and then we're going to apply the intervals from 1 to 2. So let's take this example. I want to find the definite integral of x squared, but between 1 and 2. Here we go. So I normally do like a nice square box here, an interval of 1 to 2, smallest value on the bottom, larger value on the top. What's the antiderivative of x squared? Can I please have, let's go with Samuel. What's the antiderivative of x squared?
Add 1 to the pound, x power 3 and divide by 1.
Good. So x cubed over 3. You can put a plus c, but you realize that by putting a plus c and you do the fundamental theory calculus, it will cancel out anyway. So you don't have to put it in there, but you can do it if you like. I personally can't be bothered once I get to definite integrals. Moving on. So now, remember fundamental theory calculus says it is f of b minus f of a. So in this case, this is my f of x. So that means what I'm doing is I'm substituting 2 in. I'm finding f of 2 subtract f of 1, which really is saying 2 cubed over 3, take away 1 cubed over 3. Okay, using fundamental theory calculus there. So let's simplify that. 2 cubed is 8 on 3. Take away 1 on 3. And that gives me an answer of 7 on 3. Again, you can do this on a calculator as well. The shortcut, if you didn't know, is Shift and the plus button. That will give you the antiderivative. So if I bring up my calculator, Shift plus, it gives you the integrand quickly. So you can go from 1 to 2 of x squared dx, and you get your 7 on 3. Okay? Yep.
Is there an easy way you can do second derivative of the case rather than doing derivative and then doing it again?
That's a good point. Let's do another example. Example 2. Same idea, same skills as last week. You got to find the antiderivative of this first before you apply the interval. So here we go. Same thing. Square brackets. It's between 8 to 10. Who wants to have a go? Square root of 2x minus 5 is the same thing as saying 2x minus 5 to the power of half. Anyone remember the rules for this one? What's the antiderivative of this one? Let's go with Mia. You forgot. Let's go with Tara then. Oh yeah, you weren't here. What about Serena? Oh, she's doing? What about Charlotte? Oh, who wants to have a go then? Hands up.
I'll take it for a spin.
All right, Rango.
Okay, so you get your 2x minus 5, you've got to the half, so you add 1, so you get 3 over 2.
Yep, so we're adding 1 to the power.
Yep, and then you get 2 over 3 times 2x minus 5 to the power of 3 over 2.
Oh, okay, let's say that again. You said 2 over 3.
2 over 3.
Yep.
Bracket, 2x minus 5.
2x minus 5.
Close bracket, and then to the power of 3 over 2.
Yes.
Plus,
Ooh, missing one small detail. I'll show you the rule again. Just as a hint, ax plus b to the power of n or r. But if r is not equal to -1. Anyone remember what? So Rango's got the correct idea. It was 1 on r plus 1. He's got that bit. Times the ax plus b to the r plus 1. Missing one small detail. Take the a out. So remember, if we did chain rule, if we were to derive it, you would have derived the inside and you would have multiplied the outside by a. So when you do the antiderivative, you have to do the reverse. So instead of timesing by a, there is also one more bit. There's a 1 on a there as well. So in your formula, it was 1 over a. I think I gave it to you guys as n plus 1. And then ax plus b to the power of n plus 1. I think your textbooks might use r, but regardless, the point is the power. So if the power is not -1, so then that's referring to log. That r there, that's a half, so half plus 1, which is 3 on 2. That's how Rango had 2 and 3. 1 divided by 3 over 2 becomes 1 times 2 and 3. So that's how you got 2 and 3 at the front, which is correct. The part that it was missing was the a coefficient of x. There should be the a at the front. The denominator as well. So what we're missing here is just multiplying by 1 on 2. And let me just pull in the video. Here we go. Between 8 to 10. 2's cancel out. So you're doing 1/3 of 2x minus 5 all to the power of 3 on 2. And using definite integrals, we are then substituting f of b minus f of a. So in this case, we're doing 1/3 of 2 times 10 minus 5 to the power of 3 on 2. I use a massive bracket here. Minus 1/3 of 2 times 8 minus 5 to the power 3 on 2. I hope this works out nicely. Has anyone done it? Does it work out nicely? No? All right, let's try. Doesn't look like it will. 2 times 10 is 20. 20 minus 5 is 15. So we've got 15 to the power of 3 on 2 over 3. Take away 2 times 8 is 16. 16 minus 5 is 11. So I got 11 to the power of 3 on 2 cubed. I guess you can write what? 15, 3 on 2, take away 11, 3 on 2, all over 3. Can I simplify 15, 3 on 2? That's like square root of 15 and then cubing it.
Which is 15 times the square root of 15.
Oh, that's kind of nice.
Minus, yeah, I think that's as simplified as you get, unless you use a calculator to get the decimals. Did you get a more simplified version? No. I think that is the best you can do. That's, yeah, like Pat said, that's the same thing as saying 15 times root 15 minus that's 11 times root 11. And I don't think you can simplify root 15 any further, so... Oh, the 3 and the 15 maybe? So what? That becomes 5 root 15 minus 11 on 3. Something like that. Regardless, they all seem the same version of each other, so probably just change the decimals or one or the other. Okay. So far, so good. So you can see definite integrals is combining indefinite, so you've got to do the indefinite bit, and then you apply fundamental derivative calculus f of b minus f of a, f of b minus f of a. Okay, and that gives you a value, not a function, so all of it should give you a value. If you're ready, flip over to the next page. Let's have a look. I'm going to pause the video. Two questions are going to be really tricky. So the next two is problem solving, where you're actually flipping the area, but I have a feeling we might be pressed for time. I might give you a bit of a break, and we might touch base on it again next session. But we'll see how we go. We'll see how we go. Because I think it could be a bit much with negative area. Let's just try this first. So if you know that the integration of h of x between 0 and 4 has an area value of 5 units, squared units, how do we work all of these?
Let's do like lap or something.
You can just fill it in the end.
Yeah, we'll go with
Ryan freaking said. Hey, yours phone.
doesn't make sense.
In the value for the 3x.
Oh,
I'm saying a major form C.
Oh, God. Please.
Physics stuff. Yes. See? I'm not the only one.
No, I don't say because like, oh, physics is so easy. I
Physics
I researched that as well. It's hard.
Oh yeah, well, they're kind of like
And it's just like I don't care. I just that freaking moment.
too busy. Too bored.
Oh my god. Freaking like, what you like, can't use.
Yeah.
Yeah,
doing so much work.
it's like cool work. How is shit?
Yeah, it's
It can't that much harder.
It's easier than business. This is so much easier.
Dude, this is like 10 so like a lot harder. Isn't there difference in scale?
It's very fun.
Scaling is
You reckon? Cam is 3 times. Cam goes up like 6, 7.
Like I'd say chem is 6. Right, I think chem is like twice as easy as physics.
Ben agrees. I don't know why physics does it nothing.
It's a pretty
It's because all the nerds do physics that don't do like gap.
It's because the people that do physics do it because they good. So that's why the scale is down. Like they'll do chemical.
I should have done it.
What about 2 more minutes?
Right after like some of the stuff we do in physics isn't ever useful. They just dump down the formulas a lot so you can do it with like the physics class. But like how you're actually supposed to do physics is like what the special class teaches. Like the different equations and stuff.
You should have done physics. I have stuff to do.
Wait, that was
Put the 4 and the 0 on the other side. The other side.
holy shit. Wait, how did you know?
1 more minute.
I need to watch more number red. It's fine. It's fun.
Oh, that was called metal. Metal. Yeah, every age.
Maybe I'll give you an intro to the next example, but don't have to do.
Big way.
All right, team, let's check your answers. First one, property. You can take out the 2, so 2 times this. Since we already know that's equal to 5, so double 5 should be 10. Hands up, you got the first one right. Okay, good, excellent. Second one, I did a bit of a cheeky thing, but I just thought it might help you visualize the problem. You can do antiderive of 3, which is 3x, and then sub in the values. You can sub in, so it'll be 3x, and then sub in 0, 4. So it becomes 3 times 4, take away 3 times 0, which ends up in 12. What I did was I did it visually. So I saw 3 as your constant y value, it's a horizontal line, between 0 and 4, so it's really the area of a rectangle. 0 to 4 is distance 4, times 3, so 4 times 3 I knew was 12. And I could do that for the next one down here as well. So when you have antiderive of 1, I'm just thinking it's a height of 1 and it's a base of 4, so 4 times 1 gives me an area of 4 just for that one there as well. So constants are nice to visualize. So that's what I meant by a cheeky one. I just did 5 plus 12, gives me 17 squared units there. This one was the negative area property. So we know that A to B, you can swap it around to become B to A. And it's a negative version, and hence negative 5. D was pretty much similar to B. And again, I did the same thing by observation. But again, you could do sub in 4, sub in 0. So just horizontal line of 1. Distance between 0 and 4. So 4 times 1 is 4. And the last one, you can use, again, the antiderivative x, sub it in. Or I just visualized it as well. I said linear x, so width is 4, height, subbing in 4, so that is also 4. So 4 by 4 is 16, triangle's half of that. So half 16 is 8. So I already know it's 8 minus 8 is negative 3. So that's another way of doing it as well. Can I get a show of hands who've got all 5 correct? All 5 correct? Good, good. Okay, some, all right, not too bad. Last bit of notes, and then I'll leave the rest of the session for you and we'll catch up onto this bit again. But just these notes here to fill in, and I'll give you a direction for the second one. Whether you want to do it or not, that's going to be up to you. Here we go. Area under the curve. Area under the curve or the x-axis is considered negative. If it's above the x-axis, it's positive. You can use that property to talk about negative area. And we calculate the area of different regions. So that's where I was talking about. Some will go below the x-axis and above the x-axis. You need to split the interval up. So split them up and then add them individually or together. Okay, so when you have ones that go in between, split them up, and then we make them all positive to add them. That's if you're trying to find total area. So the difference between total areas that you do have to split them, if they're not asking for total area, just finding the antiderivative or the definite integral, then that will likely be a net signed area. Okay, so it will add all the negatives and positives and gives you an overall value. That's different to total area. So read the question carefully if they are asking for the definite integral, which is signed area, versus total area. Most times it's likely it's total area because it shows your ability to work with the different regions. So this question's a nice one, just to give you a sort of an idea. First part, find the coordinates A and B. All of you should be able to find that. X-intercept, Y-intercept. So you'll be able to find A and B. Once you find A and B, what's interesting is part B.
It's cool.
Find the exact area of the shaded region by evaluating. So you might be questioning, where did this come from? This is the result of rearranging your equation. Y squared equals 9 times 1 minus x. You rearrange it such that you have an x equals 2. Okay, so normally when you're integrating, if you were to integrate this function, what you would have done is you would have said y is equal to, also this function, y is equal to the root 9 times 1 minus x. But when you square root, there's a plus and a minus because you got the top half and you got a bottom half. So if you were to integrate it to find the area, you integrate it between 0 to wherever this B point is, capital B, and it would have been the positive root of 9, 1 minus x, dx. So notice dx is with respect to the rectangles are made along the x-axis. The one that the question's asking, notice it is in dy. So that's a hint that instead of doing rectangles this way, we're now doing rectangles this way. Okay, so what's the benefit of doing that? In some questions, sometimes antideriving this function along the x-axis is harder because we don't have the rules for them. But if you antiderive along the vertical axis, it may be easier. So that's what this table is sort of highlighting without actually teaching you that little trick. And so what they did is, how do you integrate it along the y-axis? Means you change everything. You change, instead of delta x, it becomes delta y. That means all the equations have to be in terms of y. So if it has to be in terms of y, expand the brackets. Move the 9s across, so that becomes what? 9x equals 9 minus y squared. Divide both sides by 9. And that's the equivalent equation, but just x in terms of y. So that means now, when you say find the antiderivative of 1 minus y squared 9, it is in terms of y. So essentially you're making rectangles this way. You're finding the area under the curve as delta y changes. Okay, so the width of each rectangle is now along the vertical axis. And that's easier to do. That's because you've learned how to antiderive powers and constants. Whereas the other way might be a bit harder depending on the functions. Okay, so I'm going to leave it there. Next session I'll work more on this again, because the last question on the last page works on that idea a bit more tricky. Okay, so have a go if you're sort of game enough to work with that now, but if not, work on your previous skills. Okay, so definite integrals, indefinite integrals are key. But let's stop there.